Cotter and knuckle joints are two types of mechanical joints used in engineering and mechanics to connect two or more parts. A cotter joint is a type of joint that uses a wedge-shaped piece, cotter, to hold two parts together. It is commonly used to connect a shaft to a hub in machinery and is known for its simplicity and ease of use. The cotter is inserted into a slot in the shaft and the hub and then driven through with a hammer, which secures the two parts in place. A knuckle joint is a type of joint that allows for a limited range of motion in one direction. It is commonly used to connect two parts that need to pivot or rotate relative to one another. The knuckle joint is made up of a rod with a spherical joint at one end and a socket at the other, with a pin connecting the two. The joint can pivot within the socket, allowing for limited movement in one direction. Both the cotter joint and the knuckle joint have their own strengths and weaknesses, and the choice between the two often depends on the specific requirements of the application. In general, cotter joints are preferred for applications where a permanent connection is needed, while knuckle joints are preferred for applications that require limited movement or pivoting. The design procedure of cotter and knuckle joints generally involves the following steps. Determine the loads. The first step in designing a cotter or knuckle joint is to determine the loads that will be acting on the joint. This includes both static and dynamic loads, as well as any additional loads that may result from environmental factors such as temperature, vibration, and shock. Select the appropriate materials. Based on the loads that will be acting on the joint, the appropriate materials must be selected for the components of the joint. This includes the cotter or knuckle, the shaft, the hub, and any other components that will be involved in the joint. Calculate the dimensions. The dimensions of the cotter or knuckle joint must be calculated based on the loads and materials selected. This includes determining the size of the cotter or knuckle, the size and shape of the slot in the shaft and hub, and the size of the pin used to connect the two parts. Perform stress analysis. A stress analysis must be performed to determine the strength and stability of the joint under the loads that will be acting on it. This includes calculating the maximum stresses and deformations that will occur in the components of the joint. Validate the design. The design must be validated by testing the joint under simulated loads. This can be done through physical testing or through computer simulations. The results of these tests must be compared to the predictions made in the stress analysis to ensure that the joint will perform as expected. Refine the design. If necessary, the design can be refined based on the results of the validation testing. This may involve adjusting the dimensions of the components or selecting alternative materials. It is important to follow good engineering practices when designing cotter and knuckle joints, including using materials with appropriate strength and fatigue properties, and considering environmental factors that may impact the performance of the joint over time. There are several formulas used in the design of cotter and knuckle joints. Some of the most commonly used formulas include force equilibrium. The force equilibrium equation is used to calculate the forces acting on the joint, which are then used to determine the strength and stability of the joint. The equation states that the sum of the forces acting on the joint must equal 0. F1 plus F2 plus F3 plus equals 0. Where F1, F2, F3, etc. represent the forces acting on the joint. Stress analysis. Stress analysis is used to determine the maximum stresses and deformations that will occur in the components of the joint under the loads that will be acting on it. The formula for stress is given by sigma equals Fa, where sigma is the stress, F is the force, and A is the cross-sectional area of the component. Torque. The formula for torque is used to calculate the amount of twisting force acting on the joint, which is important in determining the stability of the joint. The formula for torque is given by T equals Fr, where T is the torque, F is the force, and R is the distance from the axis of rotation to the point where the force is applied. D equals 4Fl, pi sigma. These are just a few of the many formulas used in the design of cotter and knuckle joints. The specific formulas used will depend on the requirements of the application and the materials used in the joint.